Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf bin Harizan. So, I'm from Mechanical Engineering, semester 7 in UITM Shah Alam. So, today I will like to present about the analysis of friction stir welding of aluminum alloys of AA5083 and AA6061 using Taguchi method. So, this is my final year project 1. Okay, first we start with introduction. Okay, first we go to the introduction or background. So as we know, friction stir welding, or known as FSW, is developed by Wayne Thomas Welding Institute (TWI) in December 1999. Okay, so this process is known as solid state welding, which is new eras for the welding technology. So the P mixes the material of the component to be welded. So the tool shoulder is in charge of reducing the heat and holding the pelletized material in the weld region. So the heat producing when the friction happen. So next, the Taguchi is applied to get the better result. Okay, next we go to the literature review. Friction stir welding is known as a new welding process, bring benefits over traditional welding procedures because this is a new technology in welding world. Okay, so the benefit of this friction stir welding is to improve the mechanical qualities, lower residual stress, deformation, and a lower incidence of faults. So the friction stir welding technique is also commonly considered as an alternative to fastener, riveted, and arc welding joining technique. Okay, next we go to the problem statement or objective. So the problem statement we have two here. First, to ensure the mechanical characteristic of the various specimen of friction stir welding, such as tensile strength and microstructure, including fusion zone and head effector zone. So the second problem statement is to improve the friction stir welding process variables for diverse materials. Okay, next we go to the scope and limitation project. So the dimension used is 200 times with 150 and 6 millimeter for each material, and the probing tool is a cylinder made of SS304 with a 20 millimeter shoulder diameter and 5 millimeter pin diameter and 5.8 millimeter pin depth. Okay, so we use two different aluminum alloys, which is 5083 and 6061. So the equipment that used for the FSW is CNC milling machine, because that is the only one that we have in UITM Shah Alam. Okay, next we go to the methodology. So here we have 5 methodology. First, specimen preparation. Second, material selection. Third, welding parameters. Fourth, test coupon. And fifth is preparation for welding. Okay, so the first methodology is the specimen preparation. So as we can see in the white figures, there is the parameters for the two different types of alloy, which is 5083 and 6061. So the dimension of the materials utilized are 200 times with 150 and 6 millimeter for each material as specified. For the second methodology is material selection. So in this experiment, we use two different types of alloy, which is AA5083 and AA6061. The purpose of use these two type of alloys is because they are good in mechanical qualities. So when we combine of these two type of alloy, we get many advantages such as height specific strength, improved fatigue life, and weight advantage are provided by the microstructure. As we can see in the figures, the shiny one is the 6061 because it more shine compared to 5083. Okay, so the third methodology is welding parameters. So the rotating speed is between 650 and 1400. So the transfer speed between 49 to 2733 millimeter per minute, and the tight angle should be between 1 degree to 2 degree. So as we can see in the tables, there's 9 experiment with different rotational speed and transverse speed. So this is the features of the tip angle, rotational speed, and the traveling speed. For the fourth methodology is test coupon. So there is two test coupon here, which is tensile sample preparation and the microstructure sample preparation. As we can see, the microstructure sample preparation is the shape as the rectangular, the smallest rectangular in the plate. So tensile sample preparation is taken from the friction stir weld butt welds, which are made up two specimens of each welding. So for the microstructure is taken from the weldment of the butt welds friction stir welding, which is consists of one specimen of each welding. Okay, next we go to the preparation for welding. This is the last methodology. So first is friction stir welding. So friction stir welding is the main purpose of this experiment. So the spinning friction stir stool is then placed into the weld joint until the two shoulder makes contact with the upper surface of the plate, at which point the process starts. So the CNC milling machine, by varying the input parameters of three different levels, the vertical CNC machine is put through 9 runs of an experiment. This the friction stir welding procedure that is carried out using a rotating welding probe. So the probe tool is a circular pin tool with dimension of 20 mm shoulder, 5 mm and 5.8 mm pin length are sort of pins that employed. So as we can see in the figures, there is the probe tool with the dimension and the probe tool in the laboratory in the UITM Shalam. Next, we go to the last, which is expected result. As the transverse speed increase, the material flows more plastically and produce less heat. Means that when the transverse speed increase, the plate didn't get the enough heat to doing the stir welding. Second, the metallurgic change, including the strengthening, will be slower as the transverse speed increase. As the rotational speed is increasing, the heat generated more efficiently and strengthening when it is start frictional wet, even the transverse speed is increasing. For the fourth, the surface of the plate is smoothly wet and fused at the middle when the experiment used the highest of transverse speed. The highest rotational speed, the less time to generate heat from friction weld. The lowest rotational speed will produce defects at the beginning of the metallurgy section because not produce enough heat to cool and also can cause fragment. So as we can see for the first figures, there is in the beginning there is smooth welding until the last there is a growth and flash defects on the plate. For the second pictures, the plate is not get the suitable heat, so the welding become like that. That's all for me. Thank you for listening.